Hey guys, I'm Clint with ATS Diesel. You know, today we're staring down the barrel of a gun, it would seem, with all the EPA regs. And you know, there's a lot of chatter out there. There's a lot of concerns. There's a lot of talks about what EPA is doing to our industry. And I suppose to some degree, rightfully so. It's not just our industry they're after. They're after everybody. The difference is the diesel industry hasn't played real nice, with them for a while, and we got on the target, so we're cleaning up our act. And we're doing it. I'm really not concerned about it at all. But with that, there's a lot of concerns. I mean, there's a lot of people freaking out. I mean, there's talks on forums and these Facebook chats and everywhere else. And there's just, I think, a lot of alarm that doesn't need to be out there. So I'm going to take a few minutes and kind of talk through some of that and why I think that we need to relax a little bit, work with the technologies, and certainly can prove that technologies are there to work in our favor and benefit. And they're a lot of fun to work with too. I mean, these things we're getting big power out of these diesels, so we're certainly not taking a step back, when we utilize what we've learned over the last 10 years on how to make these things work. And the cool thing about it is we're not under fire for it because we're doing what they ask. So this is my story. So this is a big step, with diesel performance and emissions. And with that being said, there's a lot of misunderstanding that I think we can kind of clear up, that we're going to start educating and talking about some of these systems and kind of start clearing this up. So those of you that are concerned about performance or diesel going away, you can make an educated decision based on what you're buying. All the manufacturers were forced into getting emissions on. What we're going through today is no different than what we went through in the 70s. You got to face it. I mean, back in the 70s, 78, 79, when these after treatment systems came out, they had EGR and CATs, the catalytic converters. I mean, they absolutely destroyed the performance of these vehicles, but it was more so not understanding how to tune the engines and having a carburetor, for instance, instead of having fuel injection. So as we kind of moved through that, it took about 10 years, and all of a sudden, we were building much more power than we were on the open exhaust systems, with no emissions on them. So in 07, we kind of fell into the same thing. A lot of you guys are talking about selling your diesels and buying a gas truck. Short of telling you that's about the stupidest thing I've ever heard, I'm going to tell you that's probably about the stupidest thing I've ever heard, and let me tell you why. Let's go back to 07. Okay, so prior to the after treatment systems being on these vehicles that were mandated in 07, basically 07 and a half, the vehicles were open exhaust, right? So that means all the engines were uncapped. You could easily turn up the fuel and, of course, get huge increases in power. You also start getting a lot of black smoke. You still need to increase that air-fuel ratio, which means more turbo, to some degree, which I'll talk much more about shortly. But the key is when we started moving into this emissions on thing, the government mandated the manufacturers to put emissions on these trucks. And frankly, I mean, it wasn't ready. Pretty much if we break diesels down, we have prior to 07, we have 07 to roughly, 11 or 12, depending on the manufacturer, and then 13 to current. So a little bit later, I'm going to focus on the 13 to current and explain why, but right now I want to talk a little bit about the mid-year gap trucks, which is basically that 07 to 11 trucks. The best way to kind of identify that is trucks that are not running urea. Urea is, the diesel exhaust fluid you stick in the separate tank, and that sprays into the exhaust, and it has a great function. Well, trucks prior to that did not have the urea were really handicapped, and they were limited due to what the urea does. So when this happened in 07, I cannot tell you how many of our customers freaked out. I mean, we're talking working guys, guys that are pulling concrete around, landscapers, guys that are hot shotters, driving trucks. I mean, we all drive diesel trucks because we have to pull weight. Generally you want the bigger power, you need the bigger power to do the job. These guys go into the gas trucks, and literally, I mean, within 6 to 8 months, they were all back here. I mean, they were worn out. Like, I can't get the power out of this thing. They want them turned up. You can't turn them up. It's a normally aspirated gas motor. They're just revving the heck out of them, trying to get the work done. And yeah, they got the work done, but I mean, at 60,000 miles, they are worn out. Like, they don't work anymore. So guess what? Everybody went back into the diesel trucks. Well, At that point, everybody was also deleting. So we were talking 07, 08, 09, in the cowboy days, up to just recently, that trucks were literally anybody who was driving these trucks were deleting the trucks. And I get it that the technology on the early trucks, 07, 08, 9, 10, really the pre-urea trucks, they really didn't work well. Some worked better than others. Fact is, they would generally make it, the 50, 100,000 miles if they were driven properly, if they were going through a heat cycle, if they weren't modified. And that was the big problem. Modifying an early diesel truck with a DPF on it is, it's problematic. I mean, there's only so much you can do. There's a maintenance cycle that you'll have to go through with the EGR. There's basically a maintenance cycle you're going to have to go through with the DPF because they do clog, they don't generate properly. I also want to add, talk about some of the technology changes, right? Kind of what happened leading up to that. When the manufacturers came out and they were forced to put the emission systems on these early trucks, they weren't ready, but they were forced to do it. So they kind of came out with something that was just being developed, that was not really tested. The durability testing was barely there. Fact is, they were forced to put it on, so it came out and it kind of worked. A 6.4 Ford will generally not work very well. You can absolutely not modify them at all. A Cummins works a little bit better. A GM you can kind of work through, but again, prior to the urea trucks, they just didn't work. Well, this wonderful thing happened, and it's called technology. So as we're fighting through it, and the aftermarket, we're understanding this after treatment system and what happens with EGR and how we tune, and injector pressures start going up. Well, technology finally started catching hold, and somewhere around 13 is when most of the manufacturers really started figuring this out. They figured out that, hey, in order for us to hit these emissions protocols, we have to do X, Y, and Z in the after treatment system, right? Well, we also are trying to cater to our customers, which our customers want horsepower. they need torque. And that is what the diesel gives you that the gasoline motor just doesn't give you. I mean, I've got several gas vehicles. They're great. When I ask them to do work, I leave them at home. They don't do the job. I drive my diesels to do all the work. And what we have today is newer diesels that have an enormous amount of technology in it. I mean, everything has stepped up. The injectors have gotten better. The injector pressures have gone up. And what's key about that is you have to atomize fuel. When you explode fuel, when you inject it into the cylinder, you have to burn it. If you don't burn it, then you have black smoke, like the older days of the 5.9, for instance. They actually smoked quite a bit because they weren't really clean. They were certainly cleaner than a 24 valve. And then common rail came out and they got much cleaner. And then the 6.7 came out, injector rail pressures raised a little bit, the injector technology changed. So all of a sudden we started converting more fuel into actual mechanical energy, which is what pushes the piston down. Well, we start converting that fuel more efficiently into a cleaner burn. That means that we're going to, one, make more power, but most importantly, number two, it gets cleaner, which means we don't build the particulate that is shooting through the exhaust system into the turbo and then eventually into the filter, which we call the DPF. So as that technology starts to increase, we start raising fuel pressure and get better injectors, then the last thing we want to start increasing timing. Well, as soon as you increase timing, guess what happens? Power goes up, but the nasty exhaust, the stuff that the EPA hates, which is NOx, skyrockets. So as we start building more power and increasing timing and cleaning that engine up, then all of a sudden we trade particulate matter for NOx. And the NOx is really the harmful, invisible gas that everybody's concerned about, and that's also why we have secondary after-treatment system in the exhaust. And then that's where urea comes in. So the urea is injected into the exhaust as the exhaust is coming out, and it goes through the DPF. It might be before or after, it doesn't really matter. But we basically scrub the particulate from the airflow, so it goes from black smoke or maybe a gray mist of particulate, collapses, gets in the filter, and then it starts going out the exhaust system, and then urea is mixed with the NOx, and it's basically transformed into a less poisonous gas, something that the EPA is okay with us emitting. So when we start tuning these trucks and we start upping power, instead of looking at, we're just going to turn fuel up on these trucks and give it more fuel to basically burn, to make more power, to make more heat, to drive the turbo harder, so hopefully we can make some more boosts. We now have to look at these systems that it's an entire engineered system. So we have to look at the fuel injector, we have to look at the injection system, we have to look at the EGR, we have to look at the turbo, we have to look at the after treatment system. And we're monitoring that airflow as it goes through, as it comes in from atmospheric through the air filter, into the turbocharger, through the intercooler, into the engine, in the exhaust manifold, through the turbo, into the after treatment system, right? So if we turn fuel up too quickly, then what do? We get a little bit more heat, but we also get particulate matter, which is black smoke. And that particulate matter fills up the DPF. The DPF begins to restrict. Now we have back pressure, which means we have less airflow in the engine, which means we're going to have less power and we're going to have more black smoke. So it's this rapid fire problem that happens in the diesel engine if it's not tuned properly. Well, we understand these things and we know how to get around them, we know how to fix them. And really today, what that's yielding with the technology of these 13 and newer trucks is we can modify all of those systems a little bit at a time and get these power levels that are equivalent to what we were seeing of the old 06 and 07 trucks. So it's a very exciting time. One of the other questions that I see continue to come up is EGR. I think EGR is really misunderstood. Right now, at this time and age, we really need to embrace EGR because it really is our friend. We need to embrace it just like we're embracing urea. If we want to drive a diesel and we want a high horsepower, good running diesel, we are stuck with EGR until we come out with some mechanical or valve timing situation that is not necessarily directly mechanically connected to the engine. So we can actually use overlap, those types of things, which we don't have that technology in any of these motors. The technology we do have is EGR. So I'm going to talk about EGR a little bit. EGR is essentially used mostly at more lower RPMs. You never really completely get rid of it, but by the nature of a diesel engine, is it builds a lot of NOx at lower speeds. The number one thing that builds NOx in an engine is high cylinder temperatures. So I was talking about timing earlier. Timing's our friend. We put timing into these things, and they build a lot of power, but they also build, like I say, a lot of NOx. So we have to be careful of that. Well, when we start combining EGR with the intake system, and EGR is basically gases that are burnt. It's an inert gas, essentially. And it comes out of the exhaust, and then it's circled back in. It goes through the EGR cooler. The EGR cooler basically cools it down generally to about engine temperatures. So you're running, instead of 500, 600, 700 degrees, you're generally entering the engine at the same temperature or similar temperature than what the actual engine coolant is. And that engine coolant cools it, and then it goes into the intake system, and it's combined with your basically charge air cool, which is your turbocharger air that goes through the intercooler. So that inert gas essentially lowers NOx at a pretty impressive rate. I mean, it really does. I mean, if you start to turn EGR up a little bit, it really has a dynamic effect on the amount of poisonous gas, the NOx. Well, guess what that does for us? As soon as we start lowering those NOx, we actually get to start adding more timing in. So it really is kind of a nitrous for us, because as we're adding EGR, then we can start adding a little bit more timing, and that's giving us an end result, enough NOx that are going out of the exhaust system so the urea can counteract it. And we have a happy system, we have a happy world. We're not having to worry about EPA saying, hey, you guys are doing something you're not supposed to be doing, because we're playing within the rules that they gave us. Well, with any EGR system, it doesn't matter if it's gas or it's diesel, whatever, it's kind of dirty. And it's really not as dirty as you think on a diesel when things are tuned right. Now, if you put a big program in it, or a program that's not designed properly, so you're really maintaining that air-fuel ratio, then you're going to have a lot of soot. Okay, you're going to have a lot of black smoke. That black smoke is going to go through the EGR cooler and then is going to re-enter into the engine. Most of the stuff today, these trucks are so clean with the high pressure injection, which I can't emphasize on that enough, how important that having your fuel system in top-notch order is absolutely crucial. A lot of these trucks, pretty much all these trucks today, when we modify them, the first thing we start with is we add a CP3 pump on top of the CP4 or the existing CP3. Now we have two pumps. That is literally the first thing we do when we're building bigger power with emissions on. The reason is, you have to atomize the fuel. Number one, you have to burn the fuel properly in the cylinder or the game is over. If you are emitting too much smoke or too much particulate and send it downstream, the DPF absolutely cannot keep up, and we have what we had in the early trucks. They pack up full of particulate and they can't clean them. Something I didn't really mention is the early trucks, like I said, there was a technology shift. The early trucks basically used more of a system where the DPF would kind of pack up and pack up and pack up and get 40, 50, 60, 70, 80%. And as it would finally get to that threshold, then it basically would flip a switch like, okay, it's time to clean this thing. Guess what? We need to go into a full regen. That means spray fuel down the exhaust, light off the DPF, let it start burning down, and we're going to go on an hour drive test or hour road test to get this thing clean. And that was kind of what you had to deal with. Well, drivers that did short runs, drove around town or whatever, the DPF just couldn't really keep up. Just didn't do a very good job of it. Then when it finally did kind of keep up, then it would burn it down. Then you have this mass reaction, and you have a lot of leftover residual kind of ash and junk in the DPF. So now your DPF never really stays clean. Diesel engines really, you don't want more than a pound or so of back pressure in the exhaust system. The early trucks, they build back pressure like crazy, which was it just doesn't allow them to run. The newer trucks, not only did the technology get better as far as the hardware and the equipment, what's in them, but the system that is used to monitor them and how they're actually clean is far, far better. These trucks now, you start them up, they get at the temperature, and they are basically in a real light regen. You don't even know it. So it's kind of clean, that DPF. Older days, trucks would constantly get up to that 40, 50, 60% soot mass, which is just filling it up. That means the exhaust is getting smaller and smaller and smaller. Today's truck, you're lucky to see them, at 17, 18, maybe 20%. They're always cleaning down. They generally will stay down at like that 6 or 8% or full mode. So that means that you're not building the back pressure. The other thing that happens is these trucks are running so hot now with the engine technologies, the material of the manifolds, the material of the turbos, the material of everything is built so well, and it will live with such high heat that these trucks now are constantly running, at anywhere from 1,200 to 1,700 degrees. And it doesn't hurt the motors. You can take a Duramax, you can take a new Dodge, you can take a new Ford. You can run those things, 15 to 1,700 degrees, and they do not hurt anything. Again, that's technology change in the spray patterns on the injectors, how it's capturing heat in the cylinder. A lot of that takes place is how they're burning it, which is kind of controlling NOx, so it's always kind of a trade-off. But the fact is these newer trucks, especially like I say the 13 and newer, are designed so well. There's so much engineering that's gone into them. It's giving us a ton of bandwidth on how to modify them. So as you start adding some of this technology into it, and you start adding the EGR, then you tune it, then you're basically looking at, okay, it's time to go to the next level. And that next level is, how do you get more power out of it? Well, now we start adding some fuel. You start adding some fuel, open up that injector, you have to maintain rail pressure. That means having another injector pump. Not necessarily a lift pump, low pressure, but that means the high pressure pump. You've got to maintain, if the computer is requesting anywhere from 25 to 32,000 PSI at the injector, when that injector fires, you have to have that 30,000+ PSI so that fuel goes in the cylinder, burns, and you get the power out of it, and you don't have the particulate matter that hampers the system. Well, we kind of get to that point, and we have all this great hardware. Well, the turbos still are the limiting factor. A turbo is only so broad. The manufacturers have to design this turbo so off idle, it gets there pretty quickly. You notice all the new DPF vehicles, they're not as responsive as the older trucks. Well, I kind of take that back. The newer trucks actually kind of are, just because the turbo has been matched so well to the engine up to that 350 to 400 horsepower level, and that's where they're stopped. The manufacturers give zero bandwidth for anything over what the rated calibration is. So if they calibrate these things for, say, 395 horsepower, that is the turbo you get. That is where the turbo runs out. That is generally where everything just runs out. You're not going to flow the air. So in order to start turning these things up, do a fuel pump, maintain that atomization, add another turbo. So of course we have our twin turbo kits that you add the compound, you add the secondary turbo down below. That allows the small turbo to get up very quickly and do its job. It has the vanes in it. It drives back pressure to the EGR loop so the EGR can do its job. So then you start running the secondary turbo, and all of a sudden boost levels now, instead of capping out 30 psi, now we're 32, 35, 40, 50 psi. And with that kind of boost pressure, that allows us to maintain, get the oxygen in the engine we need, and maintain EGR. So as we build more power, start adding more timing, we really rely on a lot of that EGR. That EGR comes in the system, and then we have a higher boost level, and we have more oxygen in the cylinder. That means we can ingest more, burn more fuel, and the fuel leaves, and we're still at the same particulate level as we were at the factory calibration. And the after treatment system, the urea, scrubs the exhaust and reacts with the nitrous oxide. So now out the tailpipe is something that everybody can be happy about. So, that's kind of a brief explanation of, a lot of what we're dealing with. I mean, I'd like to open this up to questions. I know there's a lot of you out there that are, have, half information and have a lot of concerns, but I'm here to tell you that the work we've been doing, I mean, we've recently really been working a lot, with Corey Willis at PPBI on his tuning, our hardware. We've been working with Gail Banks, he's got amazing data acquisition components. They're really dedicated to making sure that this industry moves forward. And, with partners like that in the industry, and just the proof of what we've seen on these trucks, it's exciting times. I mean, this stuff is by no means going away. It's here to stay, and it's working really well. And the technology is just awesome. I mean, I've been waiting for this for a long time, just for the brains out there in these manufacturers, Ford, Dodge, GM, Cat, I mean, all these guys, Cummins, to really formulate, get all this stuff put together and really build a system that allows the after treatment system to do what it's supposed to do, and then give us the hardware up front we need to do, and now we can bolt these parts on. And I'll tell you, I mean, we're finding that even like the regen systems, if we put the compounds and add the second CP3, get the really dialed in software, that these trucks never even go into a active regeneration. They're passive the whole time. I mean, I just took a trip to California and back, and my truck, it never ever went into regen. I mean, it was in basically passive regeneration the entire time. And basically what that means is, again, I was mentioning the amount of heat that these trucks are making. Heat is vital to a DPF. I mean, you got to light them off, you got to keep them hot. So the hotter then you can run these engines to start with, then the less work you're going to have to do downstream as it cools off with additional fueling. So, just a little bit of fueling to these things keeps them nice and clean. And again, the cool thing is, another aspect is, because they never really get full, or they never pack up and then burn down, that means you're always dealing with a constant. So you're always basically dealing with a system that is almost an open exhaust. So, that means that the big economy losses that we're experiencing in the first generation, we're not seeing that now. The terrible power, the terrible mileage, the reliability aspect of it, I mean, all those things are gone. It's going away. So, we're here to work with it, and you're gonna see a lot more products from us. You're gonna see a lot more talks of kind of how we navigate through these things. We'll be meeting with Corey. He'll be here in a couple weeks, and kind of working through some more tuning and these types of things, and we'll kind of keep you guys updated. But I definitely encourage you to write in, give us some feedback on questions you have, concerns, products that you'd like to see developed. This stuff is here to stay, and it's really a good thing. So again, I just don't want you guys really freaking out, maybe because there's some bad information out there. We had some bad trucks we were working with. The future of diesel is bright. So I think we're going to be in good shape.